All right, so today for STAAR review number 4, we are going to be talking about proportional relationships. Proportional relationships. Interpreting, there's our key word. We're going to interpret the unit rate as the slope of a line. Okay? So I want everybody to take out their STAAR study guide. See if you can find information about proportional relationships. What? You found it? All right, dead center, you're right. So today we're just talking about the proportional relationships, and what do we know about proportional relationships? They go through the origin. But just to review, what do we also know about non-proportional? They don't go through the origin. That's where the y equals mx plus b comes in when we have that y-intercept that is not the origin, right? All right, I also want you to look in your STAAR study guide and see what you can find about slope. Okay, there is a box for slope-intercept form, but there's also another, that's tomorrow. There's also another box just about slope. It's on the other side. Other side, almost dead center, a little bit lower. And this brings back our vocabulary. Slope is what? How do we find slope? Rise over run. And we know the rise is the change in y. And we learned in class that I could say delta y means the change in y. Remember that little triangle was a little shortcut way to say change? Change in y over change in x. Now, I want you to look at this last little formula. This right here. You guys haven't seen that before, have you? You have, you just don't realize it. Well, what's happening? If my y's are changing, I'm trying to find the difference. So that's why it's subtraction. Change in x, how are my x's changing? By subtraction. I want you to look at your pink formula chart. Find slope of a line on your pink formula chart. Slope of a line under linear equations. It's right there. That's that same formula. But guys, that's just a formula way to say change in y over change in x. I know you can't see me writing on it. But that means the same thing, change in y over change in x. Okay? Just so you know that. All right, let's put this off to the side and let's go moving on to our problems. So remember, we're interpreting the unit rate as the slope of a line. So here, a pool is being filled with water. The graph shows the height of water in inches over time. What is the rate of change for this situation? Rate of change. The key word here is change. The key word here is change. Well, how much is the pool filling up in 1 hour? In 1 hour, it's filling up 4 inches. I know your paper, the line is just a little off of 4, but that's just from running the copies so many times. So we are filling up 4 inches per hour, right? So 4 inches per hour. Well, let's think about what does that do in terms of slope? Well, I'm going to come down here and write. I know slope is rise over run, right? Rise over run. I also know that it's the change in y over the change in x. Well, my change in y, what are the labels on my y-axis here? It's the height in inches, right? So I can write inches over what? And specifically hours, inches per hour, right? So how many inches did we say it was per hour? 4 inches for 1 hour. Guys, that's my slope right here. That's my slope. Notice my unit rate is still my slope, and we're fixing to prove it. I know that if this is my slope, I should be able to rise up 4, go over 1, and my next point should be a pretty point on this line. Okay? So let's start at the point we first found for our unit rate. How far do I need to rise up? 4. But what is the y-axis counting in? 2's. It's counting by 2, 4, 6. So how many blocks am I going to move to rise up 4, a value of 4? I'm going to rise up 2 spaces. There's 2 and there's 4. My rise is 4. What's my run? 1. And my x's are counting by 1. So I go over 1. Oh, looky there. That should be a pretty point. Do you think I could do it again and find another pretty point? Absolutely. Rise up 4. So there's 2, 4. Run 1 time. So do you see how this unit rate, and remember, a unit rate just means it is over a value of 1. 4 inches for 1 hour. My unit rate is also the same thing as the slope of my line. Okay? All right, let's look at problem number 2. A tree grows at a rate of 10 inches for every 3 years. All right, so 10 inches for every 3 years. Does that match my label with y is my inches, years is my x, right? Rise over run, change in y over change in x. So now, in order to graph this, remember, this right here is my slope. That is my unit rate. That is my slope. So I need to go up 10 inches and over 3. All right, so I need to go 10 inches for how many years? 3 years. So there's 1 year, 2 year, 3 years. There's my point. Does everybody see how I match up that rate on my graph? And now because that is my slope, I can rise up how much? What's my change in y here? 10. All right. So how many blocks do I have to go up to get a value of 10? What are they counting by?
5.
They're counting by 5s. So going up to here is 5. Going up 1 more is 10. There's my rise of 10. And how many am I going to run over?
3.
3. Is my x value counting by what? 1s. So I'm really going to run over 3 spaces. There's 1, 2, 3. There's my next point. I could do it again. I could rise up 10 more, run 3 over, 1, 2, 3. And then if I connected those points, you should see that they're going to go through the origin because we know it's proportional. It is the same as my slope because you can see my slope triangles, and my unit rate is 10 for every 3. All right, I want you to try number 3. A school requires 3 teachers for every 30 students. Draw a graph with this unit rate. 3 teachers for every 30 students. Three teachers for every 30 students. All right, so let's look at this. I know it's 3 teachers for every 30 students. So I'm going to go up and I'm going to match teachers with 3, students for how many? 30. And where those intersect, there is my first point. And then to continue on, if I need 3 more teachers, 1, 2, 3 teachers, how many more students am I going to add? 30 more. So then where is it going to go over to? It's going to go over in line with 60. So there's 10, 20, 30. So notice, my rise was 10, my run was 30. 3 teachers for every 10 students. 3 teachers for every 30 students. It's counting by tens down here. Thank you. 3 teachers for every 30 students. That is my slope, 3 over 30. Could I simplify this? Can I simplify this? What is it? Okay, bring it to me. 1 over 10. All right, thank you. If we connect these dots, this becomes my line. There's the line that would graph that. So notice, didn't we say our slope simplified to 1 over 10? Does that match up with 1 teacher, 10 students? Yeah. Yes. So even when we simplify our rate, there we go. All right, now let's look at the last one. Jaxie types 3 words for every 2 seconds. So remember, when we're talking about unit rate and slope, it's change in y over change in x. My y labels are words. My x label is minutes. So how many words? 3 words. But notice, this is 2 seconds, right? But this is on minutes. What do I need to do to get my denominator here to minutes? I have to do some multiplication. If this is 2 seconds, how many seconds are in a minute? I know there are 60 seconds in a minute, so how did the 2 go to be a 60? Times 30. But what I do to the bottom? I need to do to the top. Because would it be easy to graph 3 words for 2 seconds? That would be like maybe like barely right here. It's not a pretty point. So we're going to convert it to minutes to make it a pretty point. So how many words per minute for 60 seconds? How many? 90? Yes, I didn't write my 0. Very good. So 90 words per 60 seconds, which we know is a minute. All right, so I got to go up to 90. Uh-oh, it's not exactly a pretty point. It's going to be halfway for 1 minute. So my point would be right there. Right? Now, really remember, you only need 2 points to graph any line. I have a point here, and I also have the origin because we know it's a proportional relationship. Is that enough to graph? Absolutely. Let me graph it. And we can always double check ourselves by going up 90 more and going over to 2 minutes, which would be 120, right? So that goes up to 180 and 2 minutes. So if it's 90 words in 1 minute, how many words is it in 2 minutes? 180. That matches. It's a point on my line. Okay? So reviewing, interpreting unit rate and slope, they mean the same thing. You learned how to find unit rate in 6th grade and 7th grade. Now you're learning that, oh, unit rate is the same thing as the slope of a line if I were to graph it. Okay? All right, let's turn over. Now this side, we're going to be talking about slope and y-intercept. So let's review what slope is. What is slope? What variable did we use to represent slope? M. It's the variable m. And how do we find slope on a graph? How? Yes, I heard somebody. Rise over run. But now, what if I had a table like question number 3? How could I find slope from a table? What does the rise represent? The y, the change in y over the change in x. How far did I have to go up to rise? What was that change in the y? How far did I run over the change in x? So that's the first thing we need to remember. The second thing we need to remember is, what is a y-intercept? Okay, you can. The y-intercept is what? It is the letter B. I'm going to save that for tomorrow because we'll get into the equation tomorrow. But it is physically where it crosses the y-axis. So it's where my ordered pair is at 0 and some number. Because I'm not going over left or right any, I'm staying on the y-axis. I can only go up or down. So my ordered pair would be when x is 0, what is my y value? All right, so let's look at number 1. They want us to identify the slope and the y-intercept. All right, so slope, m equals, how do we find slope from a graph? Rise over run. What's the first thing you should notice about this line? It's going down. So what kind of slope goes down? Negative. Remember how we would write that on there? Negative. So I know automatically my slope is going to be a negative number. All right, now I need to find 2 pretty points. Well, we know the y-intercept is usually a good pretty point. Right there. Do I have another pretty point? Two, 4 is not a pretty point. 2, 4 would be way up here. 0, 4, okay. I could have also used the pretty point 2, 1 right here, but it's okay if you don't. The closer your points are together, the less you have to simplify, but you can absolutely still do it here. So we're going to make our triangle, our slope triangle. All right, so we need to first find the rise. How far did we rise up? We rose up 2, so negative 2 over. How far did we run? And we're counting by ones. 1, 2, 3, 4. Negative 2 over 4. Does that simplify? To what? Negative 1/2. So my slope is negative 1/2. I just got the negative. I just put it out in front because I knew my line was here. And then the 2 was the rise. I just like to put my negative first so I don't forget. Because I always look at my line first when dealing with slope. All right, now we need the y-intercept. Where does it cross? At what point does it cross the y-axis? It crosses it at 0, 2. So the y-intercept is 2. The ordered pair for that is 0, 2. But the actual y-intercept, it crosses the y-axis at 2. All right, I want you to try to do number 2. Slope and y-intercept. Let's look at number 2. What is your slope? Ooh, I hear a bunch of different answers. 1/4, 1/6. All right, let's work it together. Let's find two pretty points. I'm going to use the y-intercept. That's always a good one. And over to the 4, 1. Or you could have went down here. Either way. All right, I'm going to connect them with my triangle, with my slope triangle. I can even do it over here. All right, so remember it's rise over run. How far did I have to rise up in either of those triangles? 1. How far did I have to run over?
4.
So my slope is a positive 1/4. All right, what is my y-intercept? My y-intercept is -2, but if it asked for the ordered pair, it would be 0, -2. All right, so we're pretty good with graphs, yes. I said that. On your paper, listen, everybody, I need everybody to listen. I said on your paper, your line is off just a little bit, because when we run copies, it distorts the picture. Okay? So it should be off just a little bit. All right, let's go to number 3. Let's go to our chart. Let me zoom out a little bit. Chaz has some money in savings. He adds the same amount every month. Look at the table and how much did he start with and how much did he add each month? All right. Well, first we need to find, remember, each month, that's like a unit rate, right? And we said earlier on the other side that the unit rate is the same thing as the, what? As the slope. So let's find slope of a table. How do we find slope of a table? It's kind of hard to do rise over run. What do we do instead? Change in y over change in x. All right, so how much did my y's change from 60 to 100? 40. And then how much did my x's change from 1 to 3? 2. Can I simplify that? I can divide, so 40 divided by 2 is 20 over 1. So remember, this 40 right here was talking about the money, because it's the y value, right? So my 40 is my money. So it's how much money each month? $20 each month. That right there is my slope. $20 each month. But now they want to know, how much did we start with? Well, if at month 1 I had 60, how many times do I have to go backwards to get to the 0 month where we begin? I went back just 1 month to make it at 0, right? But I know that 1 month is how much money? $20. So if I have $60 at the first month, how much do I have at month 0 when I started? $40. So we started with $40 and we put in $20 every month. Now what does this 0.40 represent? The y-intercept. Very good. 0 and 40. Let me ask you this. Will this graph, if I were to graph these ordered pairs, will that make a line that goes through the origin? If my y-intercept is at 0.40? No, because remember the origin is 0, 0. So this will not go through the origin. All right, let's look at the last one. Find the y-intercept and place the correct answer on the grid. Where's the y-intercept? At 3. So my y-intercept is at 3. The ordered pair is at 0, 3. Which answer am I going to put on a griddable? 3, can I grid an ordered pair? That comma is not a decimal point. This is a decimal point. I cannot grid an ordered pair. So I need to grid the actual intercept. So do I put my 3 right here? But it's my first box. But it's a decimal. This is decimal values. What about, do I put it right here at the very beginning? No, because that is the ones, tens, hundreds place value. That's just 3 ones. So it's going to go right in front of the decimal. Now, do I have to put zeros at the end? No, these zeros are optional. Zeros in front are optional. What about the plus and minus? It's optional. The only time that it is mandatory is if it is negative. If you leave this blank, the computer will assume that it's positive. Just like we assume this number 3 right here is positive because there's no sign. If it's negative, you have to put the negative. Okay? So that was the first part of our review of slope and linear relationships. Your job now will be to complete the post assessments that go with this lesson.